Oh, the famous question, are viruses alive? Well, it depends how you look at what life is. So, why is that a hard question to answer? It's really a hard question to answer because no one has a definition of what life is yet. We really don't know. And we ask, what's a challenge in science? It's closing in on really understanding what life is. And I think we're getting closer and closer. So what do we have? We actually have a list of characteristics of properties of life, but all of those characteristics are not exclusive of life, meaning there's something we all view as something that is not living that has that characteristic. Let me give you an example. Okay, I know we're drifting some here, but a lot of people say, okay, life is defined by replication. It produces more of itself. Well, crystals do that. And crystal growth replicates on a template, just like life replicates on a template. Are crystals alive? I think most of us would say no. But that's commonly used as a property for life. So there's a series of characteristics of life. And viruses actually meet almost all of those characteristics except one. And that is all life that we know about encodes for a certain set of has a certain set of genes that encode for a set of proteins that make more proteins. These are ribosomal proteins. And so far, no virus has been discovered that does that, but all life does that. Now, I'm not convinced that we won't find that there's been a gray blurring between cells and cellular life and viruses. And what's caused that blurring? Well, what's caused it in recent years is we think of viruses as small, cells as big, viruses always being a parasite of the cells in which they replicate. Okay? But now we've discovered viruses that are actually bigger than cells, both physically and in their genetic content, meaning they have more genes than cells have genes, and they're physically bigger. So I think we're seeing this continuous spectrum between cellular life and viruses, and where a virus becomes a cell, essentially, is the question. We'll wait and see. I think looking towards the future, if you ask, let me put it this way. There's a kind of a drive in science right now to make synthetic life. I mean, de novo, starting from test tubes essentially, creating life. And if you can do that, then you obviously have some understanding of what life is. And I think the first examples of doing that aren't going to be with cellular life, but we're going to create viruses, which are very lifelike, totally de novo in the near future. And I think this will be very exciting, because this will give us a lot of insights into not only how life evolves on this planet and where it's going in evolution, but what life itself is. So stay tuned.